Hello, everyone. My name is Robin Surf. This is Math for Teachers 2, Module 4, Chapter 11. Let's go ahead and look at our first question. Should figure 1 look like figure 2 when flipped upside down? Well, let's go ahead and take a look. Let's say we draw a horizontal line directly through the center of the square. That line will look like that. So if we flip this picture on this axis, will it look like the picture in figure 2? The answer is no. So this was a mistake made by two men named Elfrin and Devante. They used a downwards translation on the top part of the figure. But actually it reflected the bottom. When you reflect the picture on the left, the picture on the right should actually look like this. So let's take a look. The triangle should stay on the right-hand side of the figure. Let's move on to question 2. And are you able to identify different types of symmetries? Is anyone able to point out which pictures might have one line of symmetry, but have no rotational symmetry? Well, let's take a look. If you look at the half circle in the bottom left, we can see it has one line of symmetry straight down the middle. Both sides are reflected across the line, this line, but if we spin this shape around, we have to come all the way back where we started to see the same object again. So if you look at the stop sign shape on the right, that has rotational symmetry because you can spin it around on its center axis and still maintain the same shape before making the complete circle. So how about which object has rotational symmetry but no reflection symmetry? If you look at the very first shape, we can actually rotate this. And we will have the same shape within 2 turns. So that is considered a rotational symmetry, but there is no way to draw a line which reflects one side over the other. The last shape I would like to point out is the hexagon again. So notice that if we spin it, it only takes just a small turn to see the same shape again. So that is considered rotational symmetry. If we draw a line like this, we can see that it is being reflected over the axis. So the stop sign is an example of both line symmetry and rotational symmetry. Another example of this is a diamond shape. Let's go ahead and move to question number 3. Do the below figures form a vertex? Well, let's take a look. So this question is asking whether or not the point at which these 3 shapes meet is actually a vertex. If they are actually a vertex, let's go ahead and look. Then these angles will add up to 360 degrees. When finding the interior angles of each shape, the pentagon angles are each 108 degrees. The hexagon's interior angles are each 120 degrees. And the angles of the octagon are each 135 degrees. So when you add each of those angles up, they actually add up to 363 degrees. So the vertex is not being formed here by these shapes. Let's go ahead and move on to question number 4. And are you able to see why the below statements are true of the diagram? Well, the two triangles QPT and SPT are being bisected by the line PT. So basically, the diamond shaped is being bisected into two distant halves. So triangles QPT and SPT are definitely congruent. The angles QPT and SPT are also being bisected by the line segment PT. So those angles are congruent as well. Well, let's take a look. The triangle PQS is actually being bisected as well by the line segment. So the two triangles it forms are QPV and SPV. So those triangles are congruent as well. Point V is the bisection of two perpendicular lines, so the angles formed will each be 90 degrees, and the angle QVP will be the right angle. Let's move on to question number 5. Can you calculate the measure of angle NOQ below? Well, let's go ahead and take a look at our diagram. This question would like to know the measure in degrees of the angle in black, NOQ. So we can draw a line here and form an equilateral triangle. Since the triangle equals 180 degrees, we know that this angle will equal 60 degrees. So let's take a look where that would be. When we draw a line here, we now have 3 equilateral angles, which will equal 360 degrees. So each one will equal 120 degrees. Now, the 3 interior angles will equal 360 degrees. So we can now set up our equation. And I did the math for you guys over to the left. And when we figure out what X equals, we can see that the final answer is going to be 30 degrees. X equals 30. Let's go ahead and move on to question number 6. What is the approximate height of the cliff? So let's take a look. I have a picture of the cliff. The problem states that by holding a ruler 2 feet in front of her eyes. So I have a picture to the left. Jenny sees that the top and the bottom points of the vertical cliff line up with marks separated by 1.5 inches. She is also about a quarter mile from the cliff. So that tells us we can actually draw a triangle which looks like this. And we can say that the ruler is here. Since the ruler is 2 feet away, we can place 2 feet here. Now, all of the corresponding angles in the smaller triangle correspond to the angles in the larger triangle. So 2 times the height of the larger triangle will equal the height of the smaller triangle, calculated into feet. And when we solve for that, the height of the larger triangle is 770. So the height of the cliff is 770 feet. Thank you for joining me on my lesson today. I hope you guys have a great day. Thank you.